Hi there, my name is Dimitri and today I'm gonna start the build of the new personal transportation vehicle. But first, let me show you the first prototype that I have built last year. So last year I built the first chassis for the personal transportation vehicle. What is this? If you don't follow the channel, I'm building a vehicle that's a single-seater that transports one single person and that has a cabin. So it's a baby between a car and a motorcycle. It has the physical dimensions of a motorcycle, but it has a cabin, you're protected. And because it's fairly narrow, only 85 centimeters, this vehicle does have a tilting system. So when you go into corner, a little bit like a motorcycle or a bicycle, it can tilt this way, it doesn't topple over. So last year I have essentially designed this configuration, which has two wheels at the front and one at the rear. The reason why I have chosen this is because it provides a few dynamic advantages. First of all, having two wheels at the front is sort of the best configuration of a three-wheeler, because when you brake, and when you brake hard, most of the weight moves to the front, which means that you have two wheels, which literally means you have twice the grip if you just have one wheel. And also this configuration is great if you want to put pedals. If you have ever seen recumbent trikes, they have two wheels at the front and one at the rear and the pedals here, and with this you can do the same. If you have one wheel at the front, there is really no space to put pedals because you have the wheel. Once I finished this project, I had two main improvements that I had to make. First one, and it was fairly easy to solve, was these ball joints. So these ball joints come from the steering system of a car. These are literally just ball joints off of, I think, a Renault Clio. And they work really well in the car. They don't really work well here. Because what happens is this vehicle, you have the suspension travel up and down, but also you have the tilting. So the vehicle tilts left and right. What that means is that I need ball joints that have a lot of travel. And frankly, there is really nothing. And this system is not good. What I only was able to get is about 12 degrees of tilting. I want to have about 20. Also, when it's tilted this hard, steering in the direction in which it tilts, it becomes very difficult. And I had some crashes because of that. Now, this is not much of an issue, as I said, because I can design a system with 2 degrees of freedom. Means that the spindle, it's attached to something that rotates, and then you have two separate bushings that allow to move up and down. So you separate the steering from the tilting. And that way, it should have pretty much unlimited travel. But the other bigger problem that I had was with the steering. As you can see, this is the seat here, and this is the steering column. Clearly a problem. Now, I don't have a cabin yet, so it's not that hard to get in and out. But once I will make the cabin, this is not very good because it makes entering and exiting very difficult. So in the second prototype, I moved the whole suspension to the front. If you've ever seen a Citroën 2CV, it's that sort of suspension. It has two arms that come to the rear, and there's a lot of nice things about that suspension. One, the steering, again, I can literally make it like in a car, and then we have two arms that get to the wheels. And that system is nice in theory. So I spent pretty much until last year in, I think, September, designing the second version, which pretty much changed all of the suspension to the front, very different suspension, in order to solve the steering. I wanted to have the steering like in a car, meaning it moves this way, you have space underneath the steering to move your feet in and out, like you have in a car. But in August, I realized one very, very important problem of that design, which is it had pretty much 100% unique components. And that is a very big problem. Now, I am designing this vehicle to be a high-performance vehicle. What do I mean by this? It needs to have minimum 130 kilometers an hour top speed. It has to have a minimum 200 kilometers of range, and it has to have a minimum 0 to 60 in 8 seconds. These are the minimum criteria. Why this criteria? It needs to be able to more than keep up with traffic. This has to have the same level of performance that every car has, so that when you are driving with other vehicles on the road, you can comfortably keep up with traffic. I don't want to have a vehicle that's really slow where people have to avoid you I think that is very dangerous for you and for other people. So this has to be like a car. That said, I really don't want to give up on the first prototype. If you live somewhere close to work and you just want to have a vehicle that you can drive in all weather, that you can pedal in all weather, this is very much doable. And I do plan to continue developing this, which means putting 2 pedals. But if I put the pedals, these 2 things here are for tilting. So if I'm pressing the pedal here, look what happens. It tilts the vehicle. So this is how you control the tilting of the vehicle with these pedals. Now, if you're going to have pedals, like in a bicycle, I cannot fit this, so I will have to use some electronic system that understands what you're doing and is going to do the tilting itself. So I do plan to continue this pretty much like a Velomobil, but a heavier, definitely. This is absolutely going to need electric power. You're not going to be able to, like a Velomobil, just powered by itself, because it's going to be heavier. It's going to be somewhere around 100 kilos. With adequate electric power, you're still going to pedal. But with the electric motor and the pedals, you're going to have something that is a sort of a Velomobil, but much higher. This is about 135 centimeters tall, so it's easy to get in and out, way more visible in traffic, way more practical. You have you're going to have a very decent luggage space, so it's a practical Velomobil. But in a way, I decided to build a higher performance version because, weirdly, the Velomobil is more complicated, because I do have the whole pedal system that I have to add, and also I do have to have all of the electric control of the tilting. So this is why I will build the motorcycle type, which is going to be self-powered, electric motor, no pedals, but the performance of a car. So let me show you what is the third prototype, because the second one, as I said, was with the suspension on the front. But let me show you the one that's going to be more user-friendly to build and hopefully more affordable and easy to get to the market. I do plan to build these things. I would love to give this to the world, and I would love to build something like this and to provide a more fuel-efficient, environmentally friendly vehicle for personal transportation. I think we absolutely need that. It's a necessity. And that means a few things. It means it needs to be repairable, it needs to be easy to maintain, and to have a lifetime of somewhere at least 2 decades. Because in electric motors, they are as efficient as they get. The batteries are going to improve, but you can put the newer batteries when they go out, because this is a light vehicle, you just have a box. So this doesn't have batteries that are integrated into the chassis, stuff that you can't replace with new ones. So this is going to be upgradable over time, which means that you're going to be able to hopefully have it for a lifetime. This is my goal. I want to build a vehicle that lasts forever. Nothing lasts forever, really, but at least 2 or 3 decades. So let me show you the third prototype. Okay, so now let's draw what I built, what I just showed you, the first prototype. So in the first prototype, if we look from the top, we have these 2 wheels at the front. Can you see that? Oh, I think that's so small. Let me draw it bigger. Okay. So you have, I think that's better. 1. These are the 2 wheels. The first prototype has a triangle suspension, which, by the way, in terms of lightness, that's the best solution. In the second prototype, and the steering is somewhere around here. Imagine if this is the seat, the steering is here. Not very usable. So last year, this is what I worked on. It had 2 suspension arms that come this way. The distance from here to here is enough to clear the steering. And these 2 suspension arms come, and this is where you have the steering box with the steering ball joints that move the steering. The advantage of this, you have the steering all the way to the front, which means if you look from the side, this is going to be the wheels. These are going to be the suspension, so the steering can do this. Meanwhile, what we have now, the steering is literally like this. Okay. So with these 2 suspension arms, now this is not all advantages, because it's a sort of simpler system from the first one, but it's a heavier system, because in the first design, I had triangles, the best of the best. Triangles are the most efficient way to design something that maximizes strength to weight. because this has these two arms, there's not really much of a way to build triangles, so you have to, in order to be rigid, just make the part bigger, but also means heavier. So I decided to give up on the second prototype, mainly because of the issues of getting the parts, or having to design and build unique parts, which ends up being expensive. And one of the things that I really believe with this project is the right to repair. I think right to repair is absolutely a necessity if we want to have environmentally friendly products. Things need to last. And it's something that today, it seems to me that manufacturers really don't care, after quite the opposite actually. Everything is designed to be disposable, everything is designed to be thrown away. So, and I think that causes massive problems, especially when you talk about cars. Electric cars today are a nightmare to fix, a nightmare to maintain, and this is why they depreciate like mad once they're bought, because once they get used, pretty much everybody is afraid of them, for good reason. This needs to be very easy to fix, very easy to maintain. This way people keep it for a long time, which also means parts need to be easily available, which means I need to use mass-produced parts. So let me show you the third prototype, which is the one that I'm going to build. So if in the first prototype, again, we had two wheels at the front and one at the rear. Second prototype is flipped. We have one wheel at the front and two wheels at the rear. Why have I decided to go with this configuration? Well, let me show you from the side. This way it's probably easier. So this is the front, one wheel. Okay, let me just design the wheels and then use another color for the frame and seat and so on and so forth. And this is the two wheels at the back. So the front wheel, because it's just one, I can literally use all of the front fork, everything from a motorcycle. Huge, because this, instead of the first prototype, which I had to have a huge amount of components to the front, this one I can literally buy everything off the shelf. This is big, because this means it's not stuff that I have to build myself, it's not stuff that takes so much time, and it's stuff that has been tested over hundreds of thousands of products. I will try and use Honda for as many parts as I can, because I see they are available everywhere, parts are easy to find everywhere, which means that something like this is affordable, and if in a decade when you need some parts, you can just go on Google, write the part, and you can easily find it. This is very important. This is why I decided to go with one front wheel instead of two. Also, the front wheel now is moved much to the front. So if you look in the first design, again, let me show you to the side. So the first design, let's see, this is the ground. This is the front wheel, and this is the rear wheel. And this is somewhere around the seat with the steering, okay? This is the front. And your feet will go until here. So the front of the vehicle is somewhere like this. Bam. This is the chassis. Okay? Imagine, let's draw the person. Let's draw me, Dimitri. So this is, okay, let me draw the double chin. Okay, these are the feet, and it should go somewhere around here with the pedals here. Okay, and this is your feet, hands with the steering. First prototype. And also the second prototype is the same, just the arms go this way. In the one that I'm going to build now, your feet are going to be here with the pedals, and it's going to be somewhere like this, tuck, and this is going to be the seat. So we're going to sit like this, okay? And the steering is going to come this way. Again, other than a little bit of space here, we have plenty of space to move our legs in and out, like in a car. We have front suspension is 1,000 times simpler than what we have here. Here I only have to take care pretty much of rake and trail, and that's about it. Moving on to the rear, again, this is a lot simpler. Because it's very much similar to what I have in the prototype. We can use two arms, and because the wheel don't have to move, I can, let's see from the top, if this is the wheel, the arms can be like this, which means they can they can hold the wheel from one side, like we see most motorcycle in most everything. Advantage of this, plenty of electric motor. I can find anything I want, and it's simple to design. I can also, I've looked in the market, and I can literally buy a lot of the rear suspension arms and just weld some of the parts that I need in order to modify the suspension, because these two arms are connected to one another. You will see this once I'm building the prototype, but there is a huge advantage of having this design because it's literally so much simpler. I can use a lot of the shelf parts, which means it's great for me to build it, and if one day this gets to the market, hopefully this is going to happen, this is very simple for the customer, which means that if something breaks one day, you don't have to buy it from me. You can just go on Google and buy the parts. This is huge. The batteries are going to be somewhere under the seat, and the two electric motors are going to be on the rear wheels. Advantage of that, this is also in the first design, is really cool. If you have two motors on each wheel, it helps you with the steering, because if you go into a corner, you can put more power to the motor on the outside, helping you corner. This is going to do the same. The actual dimensions is very similar. It's slightly longer. The first prototype was about 215 centimeters. This one is going to be 235 centimeters, so it's going to be slightly longer. Okay, if you look from the top, this design, we have one wheel, okay? And these are going to be the wheel space. We're going to have the pedals somewhere around here, and the chassis goes like this, okay? Then this is where going to be the seat, and here we are going to have the two wheels at the rear. So the chassis is going to do like this. This is a very good aerodynamic shape, and this is what's going to make this vehicle fantastically aerodynamic. Not as good as Aeromobil, nothing really is other than a plane probably, but close to that, but with a lot of practicality. Chassis does like this, so here you have a lot of luggage space under the seat again. This is going to have somewhere around 7 kilowatt-hour batteries, which should be plenty to do 200 kilometers, but we're going to see about that. I do have space to put more. So yeah, this is what I'm going to build. So hopefully this gets you as excited as I am for the new design. Hopefully I'm going to have the chassis finished in 2 to 3 months, and then to build the body, which is probably going to take more because I had already built the chassis. I know what I need to do. For the body, it's going to take a little bit longer, but I now have better tools, and hopefully I'm going to be able to do it within half a year. If you think that this project is useful, please give me a like, subscribe, and I have my email if you want to get in contact with me. Wish you all a fantastic day, and see you next time.